An Adélie penguin can spend months at sea, hunting across thousands of kilometers of open ocean. Yet it returns not just to Antarctica, not just to its colony, but to the exact same square meter of ice to find its mate. How? The Southern Ocean is a disorienting expanse of gray water and gray sky, often with no sun, stars, or landmarks for guidance. Imagine being dropped in the middle of a desert the size of a continent, with no map, and being asked to walk home. That is the challenge these birds face. The simple tools of navigation we might assume, like following the sun, are unreliable here. The answer isn't in what the penguin sees, but in a sense we can barely comprehend. Our planet is wrapped in an invisible force field. Lines of magnetic energy loop from the South Pole to the North Pole, a structure generated by the churning liquid iron core deep within the Earth. We need a compass to detect it, but for many animals, this field is as perceptible as light or sound. This is magnetoreception. The magnetic field doesn't just point north, it has an angle of inclination. It's parallel to the ground at the equator and points straight down at the poles. A penguin could, in theory, use this angle to determine its latitude. Early experiments confirmed this. Researchers fitted penguins with helmets containing magnetic coils that could alter the magnetic field around their heads. When the field was distorted, their sense of direction vanished. But how do you feel a magnetic field? The leading theory is stranger than you might think. It's not a feeling, it's a sight. Inside the penguin's eye are proteins called cryptochromes. When a photon of light strikes a cryptochrome molecule, it creates a radical pair, two electrons that are quantumly entangled, their fates linked. The Earth's magnetic field, as weak as it is, affects how these entangled electrons behave, altering the chemical reactions in the protein. This process is thought to create a pattern, a filter of light and dark, laid directly over the penguin's normal vision. In essence, the penguin might literally see the planet's magnetic compass, an unwavering guide painted across the world. A compass is useful, but it only tells you which way you're facing. It doesn't tell you where you are. To get home, you need a map. What if the magnetic field could provide both? The Earth's magnetic field isn't perfectly uniform. It has hills and valleys of intensity, known as magnetic anomalies, which are consistent year after year. A penguin, by sensing not just the direction, but also the precise strength of the field, could know its position on this magnetic map. It can feel its coordinates. So it has a quantum compass in its eye to set a course, and a magnetic map to check its position, allowing it to perform a feat of triangulation across a featureless ocean that would be impossible for a human without complex instruments. This isn't just a penguin story. Sea turtles use the magnetic field to return to the beaches where they were born. Migratory birds use it to cross continents. Even spiny lobsters crawling on the seafloor have a magnetic map to navigate their territory after storms. These animals have built a global positioning system from the fundamental physics of the planet. It requires no satellites, no external signals, just an evolved sensitivity to the invisible forces that we walk through every day. It makes you wonder, as you stand there looking at a screen, what other information, what other entire worlds are flowing through you, completely unperceived? Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.